Now, this is a bit part two of the video of talking about these five labs practicals that we kind of might have some questions on. So in this case, at the Hydrate Lab. So now, in terms of Hydrate Lab, if you look back at the blackboard, you might notice that hey, we have the Hydrate Lab. If you look at the October 24th update, you'll see a link that goes Hydrate Lab, and we'll go to something like this, which is actually the handout that you have received on the day of doing the lab. Now, the thing is this, and it's not a bad idea to look at this because this reminds you the procedure itself. So in this case, you remember that you have to record and measure out the dry crucible, weigh 2 grams, and you have to heat it, let water vapor to leave out, and you have to heat it until you get consistent reading. Okay, I'm gonna pause it, get water. My throat is. So, yeah, so you have to heat to constant mass. So that was hopefully this will ring some bell in terms of what you've done on the experiments. Now, but in terms of the calculation itself, this handout doesn't say much. However, if you go back, especially if you're in my class, you look at the 1.2.2 determining the molecular formula of a hydrate, you will find this handout, which we've gone over in class. So, and this number is actually more realistic. You are talking about, so in terms of how you do the calculations, this handout, and I believe I've gone over this example with you guys before. So in this case, the game plan is you find the mass of the water driven off. You essentially would just take this number, the initial mass minus the final mass. That should be the mass of water driven off. So the game plan will be find the mass of water driven off, determine the moles of MgCO3 and water, and then find the whole number mole ratio. You should detect this pattern by now in terms of figuring out the empirical formulas, okay? So in this case, now there is a worked example. So in this case, I'm gonna find this one here. Yeah. So in this case, this is a worked example. I've gone over this in class before. So you take the final mass minus the initial mass minus the final mass. That should give you the mass of water. You figure out what is the moles of MgCO3 and water. Now you do need to be careful because the mass of MgCO3 is the final mass. Keep in mind that you start off with the hydrate, so it will be the MgCO3 dot XH2O. You want to find what this X is, and then when you heat it, you have whatever salt it was, the anhydrate, plus whatever water, which became steam and left the crucible. So in this case, you use this mass, okay, the mass of the anhydrate, divided by the molecular formula. So this will give you the number of moles. Water, it's just what you found here, first step, divided by 18 or 18.01. This gives you this number of moles. Then later on, you find the whole number mole ratio, divide both by the smallest number. This will be the smallest number in this particular, no, this is the smallest number in this particular example. So you divide both sides by this number. So you end up having 1 here and then 4.99, something along that line. So you round to 1 to 5. So in terms of calculation, that's about it. Now, in terms of the evaluation and all, if you just want to remember, some of the evaluation you have to figure out was the hydrate heat to a constant mass. That's one other thing. And if you remember the past, in terms of half unit tests, you talk about potentially what are some of the reasons why might lose mass might be during the transfer, or some of the powder might have gone up, might have been lost, maybe wind or something along that line. Maybe, yeah, so some of the mass might be lost due to that. Um, in terms of the evaluation part, so you do want to think about, did you let the crucible, did you let the steam leave the crucible on a regular instance? Keep in mind you have to be careful though. Okay, maybe you should look at your past half unit tests for to go over that. Um, let's see. You want to think about what other water loss from here might cause a change in mass. So you want to think about that particular example. What happened during the experiment that could potentially result in increase of mass? Okay. Um, Sometimes perhaps you're heating up the substance too high, the temperature gone too high, so the anhydrate might have gone into further reaction and might react something else with the air. We don't know. So in this case, these are the things that could potentially gain mass. So again, look at the past unit tests as an example, and I'm going to move on to the third lab. Okay.